Welcome to Video 6 for this unit on linear equations, inequalities, and systems. In this video, we're going to focus on one-variable inequalities. The equation 1/2 t equals 10 is an equation in one variable. Its solution is any value of t that makes the equation true. Only t equals 20 meets that requirement, so 20 is the only solution. 1/2 t is greater than 10 is an inequality in one variable. Any value of t that makes the inequality true is a solution. 30 is one solution. 1/2 times 30 is greater than 10 is true. 48 is also a solution. 1/2 times 48 is greater than 10 is also true. An inequality has a range of values that make it true. The solution set is all the values that make the inequality true. One way to find the solution set to an inequality is by reasoning. For example, to find the solutions to 2p is less than 8, we can reason that if 2 times a value is less than 8, then that value must be less than 4. So a solution to 2p is less than 8 is any value of p that is less than 4. Another way to find the solutions to 2p is less than 8 is to solve the related equation 2p equals 8. In this case, dividing each side of the equation by 2 gives p equals 4. This point, where p is 4, is the boundary of the solution to the inequality. To find out the range of values that make the inequality true, we can try values less than and greater than 4 in our inequality and see which ones make a true statement. Let's try some values less than 4. If p equals 3, the inequality is 2 times 3 is less than 8, or 6 is less than 8, which is true. If p equals -1, the inequality is 2 times -1 is less than 8, or -2 is less than 8, which is also true. Let's try values greater than 4. If p equals 5, the inequality is 2 times 5 is less than 8, or 10 is less than 8, which is false. If p equals 12, the inequality is 2 times 12 is less than 8, or 24 is less than 8, which is also false. In general, the inequality is false when p is greater than or equal to 4, and true when p is less than 4. We can represent the solution set to an inequality by writing an inequality. p is less than 4, or by graphing on a number line. The ray pointing to the left represents all values less than 4. Writing and solving inequalities can help us make sense of the constraints in a situation and solve problems. Let's look at an example. Claire would like to buy a video game that costs $130. She has saved $48 so far, and plans on saving $5 of her allowance each week. How many weeks W will it be until she has enough money to buy the game? To represent the constraints, we can write 48 plus 5W is greater than or equal to 130. Let's reason about the solutions. Because Claire has $48 already and needs to have at least $130 to afford the game, she needs to save at least $82 more. If she saves $5 each week, it will take at least 82 divided by 5 weeks to reach $82. 82 divided by 5 is 16.4. Any time shorter than 16.4 weeks won't allow her to save enough. Assuming she saves $5 at the end of each week, instead of saving smaller amounts throughout a week, it will be at least 17 weeks before she can afford the game. We can also solve by writing and solving a related equation to find the boundary value for W, and then determine whether the solutions are less than or greater than that value. Solving the related equation 48 plus 5w equals 130 gives the solution w equals 16.4. Now we substitute 16.4 for w in the original inequality. We get 130 is greater than or equal to 130, which is true. Substituting a value greater than 16.4 for w also gives a true statement. Let's see what happens when w equals 17. We get 133 is greater than or equal to 130, which is true. Substituting a value less than 16.4 for w gives a false statement. Let's let w equal 16. We get 128 is greater than or equal to 130, which is false. The solution set is therefore w is greater than or equal to 16.4. Sometimes the structure of an inequality can help us see whether the solutions are less than or greater than a boundary value. For example, to find the solutions to 3x is greater than 8x, we can solve the equation 3x equals 8x, which gives us x equals 0. Then instead of testing values on either side of 0, we could reason as follows about the inequality. If x is a positive value, then 3x would be less than 8x. For 3x to be greater than 8x, x must include negative numbers. For the solutions to include negative values, they must be less than 0. So the solution set would be x is less than 0. Thank you for watching video 6 of 7 for this unit on linear equations, inequalities, and systems.